Hello and welcome back. Today we're going to be discussing the biological foundations of human behavior. Now, one of the questions you might be asking yourself at this point is, why are we in a criminal justice or criminology course spending our time studying biology? We're not biologists. We're not human behavioral biologists. What are we doing here? Well, I don't want you to become a human behavioral biologist per se, but there are some things we can borrow from the field of biology that are going to be instrumental in helping us understand how to deal with someone who's in crisis, how to bring someone back down to a rational state of mind, how to get them to cooperate with us as criminal justice practitioners, and how to create safe situations for the person we're dealing with, ourselves, and everybody else around us. So the better we understand these fundamental systems under which our behavior operates, the better we're able to manipulate the individual and get them to do what we need them to do in a safe way. One of the first places we need to stop is our central nervous system. Now, I'm not going to again ask you to understand everything about the central nervous system, but one part of it that's really important to us is the fight or flight mechanism. Fight or flight basically is a mechanism whereby a lot of the brain shuts down. A lot of the biological functions of your body shut down. You're in a state of crisis. There's a big giant lion chasing you, and you need to figure out how to get out of the way of this big giant lion. You don't need to think about how to digest the meal you just ate or spend a lot of energy worrying about the date you're going to have 2 weeks from now or what you're going to have for dinner later today. Your thought process, everything about what you're doing in that moment needs to be about getting away from this big, angry, ugly lion that's chasing you. And so what the fight or flight response does is it shuts down a lot of those ancillary activities. Look, we can worry about digesting food later. We can worry about this mathematical equation later. Right now, we need to focus everything on getting out of the way of this big, angry, hungry lion. And then we'll deal with everything else that comes later. But this is what needs to be the focus of our attention right now. And so automatically your body will do things through the central nervous system and through your hormonal system through the glucocorticoid response. It'll increase your heart rate. It'll provide energy to your muscles. It will take away higher thinking functions to a certain extent, impulse control, and sacrifice that to fear and energy you need to get out of this dangerous moment. Now, one thing our brains don't do a really good job of is, and we talked about this a bit last week, we don't really do a good job of distinguishing between real pain and emotional pain. They operate in the same systems, the same processes in our brain, and we don't do a good job of distinguishing between those two. The same thing is true in real and imagined stress. So I may be in the animal kingdom, and that big lion, once it's chased me, and I'm safe now, I can quickly come back to a state of relaxation. I can come back to a state of normalcy. Humans don't even have to be chased by the big giant lion in order to engage in a flight or flight response. Humans can do it simply by thinking. Think about the fact that you're going to be dead someday. And a lot of us will start getting all these negative emotions. Our heart might pick up racing a little bit. We're starting to get a little bit of that fight or flight mentality. Not full on the lion's chasing me, but we're starting to get a little bit of that. Put yourself in an emotional crisis, or put yourself in the place of someone who has a psychological disorder, where anxiety and fear is a primary component of that. And you can see how you can emotionally be placed into a situation where your body is responding to stimuli that may or may not be real. Take a person who has post-traumatic stress disorder. They may be sent to a past place where they were traumatized in some way. In their mind, they're in that place again. They're experiencing the fear. They're experiencing all the negative things going on around them, when in reality, they're in a perfectly safe environment. But in their mind, that's not where they're at. And in their response, their biological response, it's going to go with what that mind is telling it. You're going to get that glucocorticoid response, just like as if the big lion is chasing you. You're going to get higher thinking functions not working properly because your brain is so focused on getting you out of this imaginary dangerous event, this crisis situation. Sometimes we're just overwhelmed with things that happen in our life. A death of a loved one, a cheating spouse, a ton of different things can happen that can overwhelm us and put us in a state of temporary crisis where we're not thinking clearly, where we're not rationally going through everything that's going on around us. One of the things we have to do in this field is we have to think for others the way they'll think for themselves tomorrow or 2 days from now. When they're not in a state of crisis, when they're in a rational place, and they can start thinking about the consequences of what they did. Or they can start thinking about how this particular behavior isn't particularly helpful to them in their situation. Now, we're going to do a lot of work with manipulating this response, because one thing we know scientifically is that you can't be simultaneously in a state of excitation, fight or flight, and relaxation. And so if we can get your body to relax, it'll tell your mind, look, things aren't so bad, and then your mind will start relaxing as well. You can't be in both states at once. If you have an anxiety disorder, severe anxiety disorder, one of the things a psychiatrist may do is they may prescribe you medication that relaxes your muscles. Now, it does absolutely nothing to the psychology of what's going on up here, or to the neuroanatomy of the brain. It just relaxes your muscles. But your brain, through biofeedback, goes, well, my muscles are relaxing, so things must be calming down. I can turn off this glucocorticoid system, this hormonal system. I can turn off some of these fight or flight mechanisms, and I can start putting back on the rational brain, the higher thinking, the impulse control brain. And so you can begin to think more rationally and more clearly and not just be in this state of crisis. And so what we do is we recognize this dance. Behavior is largely a response to this dance between what's going on in your brain, what's going on in your body, and what's going on in your environment. I might not be able to manipulate what neurotransmitters and hormones your body is producing as a result to some real or imagined stimuli. What I can do is, through techniques of de-escalation, get you to calm down so that your brain thinks, hey, this is easing up. We're not in as much danger as we thought we were. Things are getting a little safer, and that rational thinking can start to come back through. So I can change your environment that plays on your body, and that changes your mind and in your neurology in your brain to get you into a place where you can think rationally for yourself, and we can get you to cooperate with us and do what we need you to do for everybody to be safe. The communication system of the brain and the body is basically built on neurons. Neurons, and this is a diagram of a neuron, essentially what they are is communication signaling devices in our brain that operate on electrical impulse. At the front of the brain, you've got what we call the dendrites. Now, the dendrites is where action potentials can come in, charge up the cell of the neuron. When the electrical impulse is significant enough, it can pass through what we call the axon hillock. That'll tell the neuron to fire. It'll shoot a message down the axon and into the terminals. And then that's where the neuron will release some type of neurotransmitter. And we'll talk about some of those here in a minute and what they do. Into this, what we call a synaptic gap. This is a gap between the two neurons. So enough electricity builds up. It sends an impulse, enough to overcome the axon hillock, sends a message down the axon, tells the terminal, release this neurotransmitter. And that is a message to the next neuron to do the same. Now, these neurotransmitters can't stay in the synaptic gap forever. They'll burn the neuron out. So the brain has come up with all kinds of ways to deal with these excess neurons in the synaptic gap. Sometimes they'll do what's called reuptake, where they'll have a reuptake receptor on the neuron that actually brings the neurotransmitter back into the neuron for reuse. Sometimes there'll be enzymes that are released to break down the neurotransmitters once they're in the synaptic gap. But whatever method it uses, those neurotransmitters are then wiped clean, and until another message comes through, they can be quiet. Because you can't have your brain firing all the time everywhere, or no information, no important information would ever get through. Let's talk about some of the important neurotransmitters we're going to discuss in this class. The first one is dopamine. Dopamine is popularly thought of as the pleasure drug. It's the drug or the neurotransmitter that tells you that, hey, this is a really pleasurable thing to do. You need to keep doing it, and this is an important thing for you to do. Really, it has more to do with motivation, to motivate you to do things that are necessary for your survival. When you eat something, you get a release of dopamine. When you drink water or something, you get a shot of dopamine. When you engage in sexual activity, procreation, you get a shot of dopamine. People who abuse drugs like stimulants also get an influx of dopamine. And it can overwhelm this system and increase the dopamine capacity to the point that it overrides the need to eat, the need to sleep, the need to procreate, the need to do anything except get this drug. This drug is your brain is basically being told this drug is necessary to my survival beyond everything else. And one thing we see from people who abuse stimulants, and you'll see this actually in every drug that has a physical withdrawal. The physical withdrawal is usually the opposite of whatever the drug does. So with dopamine, stimulants, they're uppers. They get you going. They get you excited. They give you a lot of pleasure. When you come off of them, a lot of people have some bouts with depression and feeling lost and lonely. And some people never really recover from that to a complete extent, because the dopamine receptors have been burnt out. They've just been fired so many times, so powerfully, that they've burnt out. And a lot of people report that they don't really feel pleasure in the things that they used to feel pleasure in doing. Hanging out with family and things. It's not enough to give them that pleasure. And that's why when you hear about people say things like, you just keep trying to get that same high you got that first time, and they never can reach it. It's because your body is adjusting to this influx of dopamine in the system, or whatever neurotransmitter it is. So your body wants to stay at a level of homeostasis, what we call homeostasis, which means just even keel. And when your body and brain is invaded by all this dopamine, well, your brain says, how can I adjust to a normal function or somewhat normal function with all this dopamine showing up everywhere? Well, let me quit producing dopamine in my brain. And so your naturally occurring dopamine isn't there as much. It's being replaced by this artificial dopamine. So when you quit using a drug that has a physical withdrawal, your body's not adjusted to that anymore. So you have no dopamine, no motivation, pleasure chemical in your body. And so it takes a while to replenish that as much as it can. Sometimes, though, it's never really completely replenished in the case of dopamine and stimulants. Norepinephrine, this has to do with stress. This is something we're going to talk a little bit about because it has to do with that fight or flight response. Norepinephrine lets you know that, hey, something in here we need to take action with, we need to concentrate on. It needs to get our focus. There's something important here. Endorphins are a very important one. Endorphins, the best way to describe them is they're our natural painkillers. Endorphins are what's released in our body to deal with pain, both physical and emotional. Remember, our brains don't do a good job of distinguishing between the two. And so these neurotransmitters help us deal with both. When a person is on opioids, they act like these endorphins in your brain. And so your brain is overwhelmed by these painkillers, and they shut down the painkiller processing units of your brain to try to make up for this influx of artificial endorphins coming into your brain. So when people come off of these narcotics, these opioids, it's usually extremely painful. It's usually something that is very hard to watch someone go through. It's extremely painful to come off of opioids. Your brain is basically not producing any natural painkillers, and it takes a while for it to catch back up and start kicking those painkillers back in. One of the things that endorphins do is they make you feel good. You know, they take away your pain. They take away your physical and emotional pain. And so if you have any emotional pain or anything like that, they're really good at dealing with that. The problem is that they can be overwhelming to your system. Glutamate is an excitatory neurotransmitter, but not excitatory in a good way. It's kind of like standing at the edge of a cliff and feeling like you're about to fall off. That type of anxiety-ridden type of stimuli. Serotonin has a lot to do with your mood stability. You see problems with serotonin levels with a lot of mood disorders like bipolar disorder, disorders like major depressive disorders, those things. So they have a lot to do with your mood, overall mood and well-being. GABA is an inhibitory transmitter. It basically acts to calm things down in your system. It acts to tell things that, you know what, just calm down. Just quiet down a bit. We also have an endocrine system, which basically is the pituitary gland, producing hormones that enter into our bodies and cause changes, both immediate and long term. So basically the hypothalamus within the limbic system, which we already talked about in the last lecture, will tell the pituitary gland to release certain hormones in response to things going on in the environment and things that are genetically predisposed. And your pituitary gland will start producing these hormones to deal with it, with whatever the situation is. There's two different types of hormones that can be released. The first ones are peptides. These are water soluble. These dissolve well in water, and they're fast acting. So these are the hormones like our glucocorticoid system we've been talking so much about. This is our stress hormones. You know, big lines coming at us. We need to act quickly. These hormones are pumped into our system and telling our body, look, get the heart rate running, get out of the way, increase energy to the muscles, let's get out of here. Steroids they don't dissolve well in water, non-soluble, and they're more slow acting. These are things like testosterone in puberty, things like that make marketed changes in the body, but they happen over a period of time. It's not like they happen in the moment, in the immediate moment. So most of what we're going to be talking about falls more in the peptides, in those glucocorticoid responses and those stress responses, and how we can play on that to calm the person down. This is the basic structure of the human brain, the most basic structure of it there is. This is called the triune brain. This basically shows the basic structures of the brain in its most simplistic form. At the base, we have the reptilian brain. This is the part of the brain that deals with a lot of automatic functions. Things like heart rate, things like blood pressure, things like body core temperature, balance, things like that. Things that we don't have to give thought to. Breathing, breathing in and out. You think about how complex of a behavior that is, yet we do it without thought. Those things happen mostly in our reptilian cortex. Next, we have the limbic system. The limbic system is the part of the brain that's the emotional brain. This is where we're going to spend a great deal of our time, is in this limbic structure, looking at things like the amygdala, which deals with fear, anxiety, and anger. We're going to be looking at structures like the hippocampus, dealing with memory and remembering these things. We're going to talk about the communication systems within this limbic structure. This is our emotional brain. This is the part of the brain that we feel emotion from. The higher brain, the neocortex, this is our area of higher learning. This is our analytical part of our brain. Our part of the brain that's very much engaged in impulse control. It's also the last part of the brain to be fully developed. Full myelination of the limbic structure, which means full connectivity of the neurocortex to the limbic structure, doesn't occur until your mid-20s. That's why the Supreme Court has said we can't execute juveniles anymore for crimes they may have committed while they were juvenile, because they're not operating with a fully functional frontal cortical area of their brain. And so we can't expect them to engage in impulse control and rational thinking the same way that we would expect other people to do. If you want to kind of visualize the difference in these two structures, think about a teenager. Most of us know a teenager, or we've been a teenager. Most teenagers can sit, if you talk to them, and tell you what the right thing to do in any given situation is. They can articulate to you why it's the right thing to do, and how you should act in that given situation. Yet when they find themselves in that situation, that's not always how they act and react to it. That's because the emotional brain is more prominent at that point, and they have less connectivity to the prefrontal cortical area. So in the moment that the decision has to be made, their impulse control doesn't quite catch it in time, and they may engage in a behavior that they kind of knew was wrong. This is also one of the first parts of the brain to start to deteriorate. So in elderly people, you might see people who you think, they just don't care. They're going to say what's on their mind. This is so-and-so, and they just let you know what they think. And a lot of that is because that impulse control is starting to deteriorate. They may not have done that 15, 20 years ago, but now they've lacked that ability to stop that impulse in the moment. Here's a better diagram of the limbic structure of the brain and some of the points and contacts we're going to talk about next week. Next week, we're going to spend a lot of time talking about the amygdala. We're going to talk a little bit about the hippocampus. The hypothalamus we'll definitely touch again. And we'll spend a lot of time in this frontal cortical area, because here we're talking about things like empathy and higher thinking and impulse control. And we're going to look at some differences in normal brains and brains of psychopaths, and kind of see how the structure and the function vary. And then we're going to talk about how we can play on some of these things going on in the biology of our mind, in our body, and in our environment to calm down situations, de-escalate crisis situations, gain compliance, and help people think for themselves as they'll think 2 days from now in a moment of crisis. Until then, I'll see you next week. Have a great one.